definition of a parabola is the set of any points, or set of all points that are the same distance away from a fixed point. We'll call that fixed point the focus, as they are from the fixed line, which we're calling a fixed line of directrix. So what we're going to start off with is a parabola that is centered at the origin. So we're going to have an ordered pair at 0, 0. And we'll draw a directrix line, and that directrix line is going to, eventually it's going to be perpendicular to the axis of symmetry for our parabola. So we're going to have a parabola that's opening up. So that means that our axis of symmetry would be vertical, and our directrix is going to be perpendicular to that. We'll call this directrix line y is equal to some negative value. We'll call it a. So that the distance from the vertex point to that directrix line is a distance of a. So if this vertex point is the point on our parabola, it is the same distance from the directrix as it is from a focal point. We're going to call our focal point f. Okay? The focal point is going to be inside the parabola. We're eventually going to have a parabola opening up again. This distance from the focal point is also going to be a, because any ordered pair that's a point on the parabola is going to be the same distance from the focal point that it is from the directrix. And we're going to open our parabola up like this. And essentially, any point that is on this parabola is situated such that the distance from that point to the focus is the same as the distance from that point to our directrix line. Ideally, if we had drawn it correctly. Probably should open it up a little bit more. Okay. Alright, so this ordered pair, the focus point is going to be situated, we have it located on the y-axis, so it's going to be situated in an ordered pair 0a. And we want to grab an ordered pair that is on the parabola. Our idea is that any point that's on the parabola is going to be the same distance from the focus as it is from the directrix. So we'll call this point P. And we'll say that this ordered pair P is located at some xy ordered pair. And again, this distance from P to F should be the same as the distance from P back to the directrix, the closest distance back to that directrix line. Well, if I'm a point on the directrix, and I'm the closest point from P to the directrix, then this line should be perpendicular to that directrix, a straight shot down to it. And if it is, then it's going to have the same x value as the x value of our point. And the y value is going to be this opposite of a, y value that's situated down here, being that it's on that directrix line. So what we're saying as far as the definition of a parabola is that if this ordered pair P has the same distance away from the focus as it does from the directrix, then it is a point on our parabola. So we'll say that in symbols over here. If the distance from P to F is the same as the distance from P back to the directrix line, then this point is a point on our parabola. So we're going to use this definition in order to derive a standard form for the equation of a parabola. And I'm going to slide a different board up here to kind of start again, to say that essentially we're looking at the distance between 2 points, from P to F and from P back to that directrix line. And those distances, we'll call this guy distance 1 and this guy distance 2. Those distances can be represented by the distance formula. So the distance from P back to F, let's come back here and see. So from P back to F, we'll have the change in the x values, quantity squared, plus the change in the y values, quantity squared. So x minus 0 squared plus y minus a quantity squared. Okay, so there's my distance 1. The other distance is going to be the distance from P back to the point on the directrix line. So let's check that guy out. So our guy P back to the directrix line, we want to find the distance between those two. So we'll say the change in the x values, which is 0, and then square that. Add it to the change in the y values. So we have x minus x quantity squared plus y minus a negative a quantity squared. And we want to set these two things equal to each other. And doing that, we'll simplify a little bit. So I'll have x squared plus y minus a is equal to, essentially, y plus a quantity squared over here on the other side. Now, any xy ordered pair that satisfies this equation is an xy ordered pair that it's a point on our parabola. So we basically want to simplify this down to get our standard form of the equation of a parabola. And what we'll do to kind of pretty it up a little is to first of all square both sides. In squaring both sides, I just get rid of these radicals. Okay? And let's do a little bit of foiling these two binomials to simplify our equation here. So we have x squared plus y squared minus 2ay plus a squared is equal to y squared plus 2ay plus a squared. And we can subtract y squared from both sides, and those y squareds are going to cancel out. Similarly, we can subtract a squared from both sides, and the a squareds cancel out. And let's add the 2ay to both sides. So that what we end up with is x squared, which is equal to, so this cancels out on the left, x squared is equal to 4ay, and this is our standard formula for the equation of a parabola with the vertex situated at the origin, which is at 0, 0, and a focus point situated at the ordered pair 0a, and a directrix line situated at the horizontal line y is equal to negative a. A couple things that we want to say about this standard form of the equation of a parabola is that if the a value, this a multiplier inside here, turns out to be a positive value, that's going to imply that our parabola is going to open up, as we had the original parabola here was opening up. Okay? And our a value being negative is going to imply that our parabola will open down. So this is our standard form of the equation of a parabola that is centered at the origin. So here we have two standard forms for the equation of a parabola that is centered at the origin, or has a vertex point at the origin. We have one where we have an x value quantity squared and a y value squared. If the x is squared, that implies that we're going to have a parabola that's opening either up or down, and we can determine if it opens up or down by looking at the value of a. If a is positive, then we'll be opening up. If a is negative, then we have a parabola opening down. If the y value is squared, that means that we're going to have a parabola opening either to the right or to the left. That is depending on whether or not the a value is positive or negative. If a is positive, we're going to open to the right, and if a is negative, we're going to open to the left. So looking at an example, we're going to graph one where we have a y squared equaling to 12x. And what we want to do is we want to rewrite this equation such that we're actually looking at this coefficient of a 4 in the equation. We want to be able to see the 4 multiplied by, in this case it would have to be 3 in order to give us that 12 that we initially started with, so that we can determine the value of A. A is going to play a role in the graph. A is greater than 0, of course, so that we are going to have a parabola that's opening to the right. Since we're y squared and our A value, which is 3, is positive, that means we're going to be opening to the right. So we rewrite our equation like this in order to see our value of A, and then we come over to our graph. So we have a parabola that's centered at the origin, or who has a vertex point that's situated at the origin. And we have a focal point that is going to be A units inside my parabola. Well, I know I'm opening to the right, so 3 units inside the parabola is going to situate me in here at the ordered pair 3, 0. Now, my focal point is 3 units inside the parabola. That's true. My directrix line is also 3 units on the back side of the focus, or the back side of the vertex. So I'm going to go 1, 2, 3 units back here, and since my parabola is opening to the right, the axis of symmetry for the parabola is a horizontal line, and therefore my directrix line is going to be vertical, perpendicular to the axis of symmetry. So since I'm passing through the x value -3, we have x is equal to -3 as our directrix line. So we know that we have a focus situated at the ordered pair 3, 0, and a directrix line situated at the vertical line x is equal to -3. Now, I'm going to graph my parabola opening to the right, but there's one more thing that I want to consider, which is how wide should this parabola be? Now, one other piece of information that we haven't talked about yet is the latus rectum. The latus rectum is essentially going to be a line. Let's get an idea of it up here. So if we have a parabola like this with a vertex and a focal point, the latus rectum is going to be a line that passes straight through the focal point, taking me from one ordered pair on the parabola to another ordered pair on the parabola. This entire piece is what we're calling that latus rectum. That latus rectum segment is going to be 4 times the A value long. Okay? Well, we know that 4 times the A value actually appears in the equation itself. It's 12. So in this particular case, the length of our latus rectum is going to be 12 units long. So that enables me to determine how wide this parabola is going to be. Well, I know that I'm going to pass through the focus, and I have a latus rectum of 12 units from top all the way to bottom, which means that I'll have 6 units up and 6 units down. And I'm just going to kind of wing it up here. I'm going to say that this ordered pair is situated at 3, 6, so 6 units up. And as well, 6 units down, we have the ordered pair 3, -6, so that the total distance between those two ordered pairs is the 12 units that is the length of my latus rectum. That is going to dictate how wide my parabola is. Pretty wide. And then the rest of the parabola is going to kind of come in out of that. Okay, so we do have a line segment here passing through the focal point to get me from one point on the parabola to another point on the parabola, and the length of that segment should be 4 times the A value long.